Good morning, good afternoon to everyone, depending where you are joining us from today. I hope everybody is safe and well in this very particular circumstances and challenging times. My name is Ismahan Ilwafi. I'm the Director General of ICBA, which stands for International Center for Saline Agriculture, which is based in Dubai in the United Arab Emirates. Thank you very much for turning into our webinar entitled Saline Agriculture, Scaling Up Opportunities and Challenges, that is hosted by FAO, the Food and Agriculture Organization of the United Nations. And this webinar is organized by the Working Group on Saline Agriculture, which was established in May 2018 in Rome in FAO headquarters, under the umbrella of the WASAG, which is the Global Framework on Water Scarcity in Agriculture. This group, it's led by ICBA, and the mission is very well aligned with the clauses number 13 and 14 on the saline farming system in salt-affected area of the prior commitment of the first WASAG International Forum in Cap Vert in 2018. So the subject is very pertinent to us as ICBA, but also is very pertinent to the world, in my view. So I'm pleased today to moderate this event. It's our first event within the WASAG Saline Agriculture Group online, but I bet we will have many from now on, I hope. So I will turn it now to His Excellency Mohammed Hussein Al-Imadi, the permanent representative of the Republic of Iran to FAO, to give us his opening remark. Your Excellency, the floor is yours.
Thank you very much, Asmana. Thank you, and good afternoon, everyone. And first of all, thanks FAO for organizing this kind of webinar, particularly with ICBA and joint work. And as Dr. Osman mentioned, actually this is an attempt which started from 2018. And of course, the main role of today and the main subject of today is the scaling up of opportunities and the challenges. And of course, we need to talk and share the information, but in the meantime, we need to know that we are living in a situation in which COVID-19 actually as a pandemic put the umbrella on the whole our activity. And I think this COVID-19 learned a lot of lessons to us. And one of the lessons we learned is the vital role of the local food system, local agriculture and local farming, which actually in such a pandemic situation can be a real sort of support to the developing countries. And of course, the new technology, there is no doubt, can help us in the process of scaling up of the saline agriculture. But in the meantime, we need to actually merge the new technologies, new research sort of experience and so on with the local knowledge, with the local agriculture and so on, in such a way to find the best way forward for future. And of course, so many examples. Now, best example is in my country. We have the canal system in the saline sort of soil, but for almost 2,000 to 3,000 years, we learn how to manage the sort of farming in the soil and the sort of saline soil and saline environment. And of course, this kind of practices by farmers can be one of the source of information along with the new technology. And as we know, salt-affected soil is a global increasing issue. It's not a sort of regional issue. And more than 100 countries, as far as I know, are affected by this issue. And it is a huge threat to food security in many regions, especially in Near East, North Africa, and Central Asia, which in the meantime have a very fragile food security system. As we know, now we are the most related countries to the import of the food, particularly in the pandemic that shows that some of our country in the Persian Gulf countries and so on, we have almost up to 90% dependence on the import of food. And that's very important that working with such environment is very important. And of course, the climate change makes the situation much fragile, much critical. That's why the trend also doesn't show any promising situation by the climate change and so on. And of course, today's discussion is a new attempt to actually identify and share best soil and water management practices for the member countries. And as we know, actually, this is one of the most important jobs that we can do. According to our information, although the COVID-19 as a virus, which the overall total weight of the whole virus in the whole world is less than 1 gram, could actually collapse the almost 35% of the whole economy. And the privilege of human being in such a situation is that they can think, they can communicate, they can cooperate, and they can actually be against the COVID-19. And that's why today, actually, webinar is one of these attempts to increase communication at the global level, to bring together different members countries with salt-affected soil, to think collectively, to learn from each other, and to actually find out new ways out of this pandemic and out of this sort of global threat like saline soil, saline agriculture. And we are here together to learn from each other, from the best practices, new technologies, and also old wisdom, which we now all of them together for combating with such a threat and all upcoming threats. Thank you very much, Ismane. Back to you. And we wish to have a good meeting today.
Thank you very much, Your Excellency, Mahdi. Thank you for reminding us of really the global issue and also of the fragility of the food system. Thank you so much. So now we're going to move to the main part of our agenda. We have a presentation by 3 speakers who will share their knowledge and experience related to the project on saline agriculture. I like very much the format that they're going to use. We have 3 colleagues. We have my colleague from ICBA, Sisi, Dr. Yonisa Angelisi Lira. We have Dr. Arjen Vos from the creator of the Salt Doctor, a social enterprise from the Netherlands. And we have Dr. Andres Paragonzalez from Sebastis in Spain. So before we start the presentation, if I can have the next slide, Rosaida, please. I would like just to mention a couple of housekeeping rules first. I would like to request everybody to mute their mic so that we can all hear our speakers clearly. If you don't mute yourself, Rosaida will mute you. Or better you do it yourself. We will have a Q&A session after the presentation. So if you have any questions or comments, please type them in the chat box on your screen, and we will put them to our speakers later, to the extent possible. Our speakers will take turn to give today's presentation, which covers the following points. They're going to start with an introduction of the topics. Then they're going to give us opportunities for cultivation of conventional vegetable crops under saline conditions. Then we will have some project on halophyte value chain in the MENA region. Then we will move at our 4th component, which is implementation of a decision support tool under saline condition, showcase from the Mediterranean region. And then we will end up with some conclusion. And here I'm going to hand the floor to Sisi to begin her presentation. Thank you, Sisi. Go ahead, please. I think, Sisi, you are muted. You need to unmute yourself if you are starting. And Rosaida, if we can have the...
So you can hear me, right?
Yes.
You can hear me. Okay, great. So I would also like to thank the attendees for participating in this exciting webinar. So I would like to start with some vexing challenges that mankind is overcoming in the last few decades. So we all know that the world population is projected to increase by 9.7 billion by 2050. And in order to meet the food demands, the agricultural production should increase by 60%. So this can hardly be achieved considering the soil and water degradation, which is further exacerbated by the climate change impact. And the climate change impact is one of the key factors that has contributed in outbreaks erupting occasionally, like the recent locust swarms in the East Africa in the past months. And impacted the nutritional status of the communities living in vulnerable areas. On top of that, we have the COVID-19 pandemic. Which of course, apart from the unfortunate outcomes and the casualties, the pandemic exposed additionally the food system weaknesses, as very well His Excellency Imadi mentioned. The lockdowns did not facilitate the logistics that much to that extent of the agricultural products. So many countries had to be pushed in order to focus on strategic planning within their countries, how they can focus on increasing the local food production, focusing on the whatever available water and land resources exist. Next slide, please. So one of the theories that have been deployed in order to recover the COVID-19 pandemic is what is called the donut economics theory. So this theory, so we can think about and we can see a green donut, which has the inner circle, which refers to the social aspect, and the outer circle refers to the environmental aspect. So in order to achieve the sustainability and the balance between the people and the environment, we should operate within the green zone. Whatever falls within the whole, this is where for the people appearing shortfalls in the all essentials of life, which of course is not desirable. And of course, when we are talking about overexploitation of Earth's resources, then we move to outside the boundaries of the outer circle where some red zones are created. So this means that the system is out of balance. So we can consider, in order for be within this green donut zone, how this sustainability can be achieved, for example, in a marginal area, for example, in a desert environment, where there are no abundant fresh water resources and productive lands to produce some food. So we have to direct our focus on an unconventional water and land resources to be utilized. So why we're focusing on saline agriculture? First of all, because it releases pressure on the fresh water resources and the productive lands. We utilize low quality water and land resources. It can also provide new sources of food, feed, biofuel, and fiber. It can generate employment opportunities for the communities living in vulnerable areas, especially including youth and women. And of course, saline agriculture can be considered for climate change mitigation and adaptation projects. Next, please. So the resources that can be used for saline agriculture implementation regarding the water resources, we could utilize the brackish groundwater wherever this is abundant and available. Seawater, reject brine from desalination, drainage water, aquaculture, effluents. Regarding the soils, we can use degraded soils like saline, sodic, and barren lands. And regarding the plants that can be used under the saline farming, within the saline farming context, we have two directions. Either to use salt-tolerant varieties of conventional crops, which can be used for moderate and low salinity levels, or halophytes for highly salt content levels. Next, please. So this graph exactly clarifies and gives better idea of what is the difference of the tolerance between halophytic group and the conventional plants group. So the halophytes, you can see of these two plants in the graph that they can really tolerate very high salinities and good growth can be achieved. Whereas the conventional crops like barley, rice, for example, they do not tolerate that higher salinity levels. Whereas within these crops, we can find salt-tolerant varieties of these conventional crops. which constitute the topic of the next part of the presentation of Arjen. So I would like to pass the floor now to Arjen to continue.
Yes,
Thank you.
Thank you, Cici. So let me just quickly share my screen for that. So hello, everybody. My name is Arjen de Vos, and I'm from the Salt Doctors. As said, this is a social enterprise from the Netherlands, and we focus on improving the crop yield under saline conditions and really bring the solutions into the hands of farmers. So we have a very practical approach, and we try to make the difference in the field because from our perspective, that's where it really matters, of course. So we have different services that we provide. It always starts with salinity assessments, but we do a lot of teaching as well for students and university staff. We do a lot of training and capacity building of farmers, NGOs, and extension officers. We can provide salt-tolerant seeds. We can help with research and setting up demonstration trials, which are very important to get the farmers familiar with saline agriculture. And we always focus on scalable solutions. So it has to be possible from a technical point of view, but also the business model for the farmer, it has to be clear, or else it's going to be really difficult to come up with this upscaling, of course. So if you're looking at salinity, it's well known that around 400 million hectares of saline soils exist. And if you assume that 1 hectare can feed around 5 people, only the saline soils already can feed up to 2 billion people. So this overall perspective is very big. And if you look at the salinity levels of these lands, the majority is actually low to only moderate saline. It's often farmers have great difficulties with salinity levels of 6 or 8 decisiemens. And that's also what we see in Bangladesh, for instance. The coastal area of Bangladesh has massive problems with salinity in the dry season, but the majority of the soils are actually below an EC of 8 decisiemens. And we see the same also in, for instance, in the east of the Nile Delta in Egypt. The majority of the soils are only moderately saline. So that has consequences for the crop selection that you have. And also, if we measure in the field, we work in a lot of different countries. And every time we take the soil samples, we do the analysis in the field, we are always surprised with either much higher salinity levels than a lot of people think. They were not aware of the fact that they had salinity issues. And sometimes a lot of farmers claim low yields because of salinity, but if you actually measure the salinity levels, it's quite low to moderate. So all the places we go to, also there we find mostly moderately saline salinity levels in the soil. So if we look at a lot of research that we've done on Texel in the Netherlands, we've tested around 800 varieties of 50 different crops. Yeah, we're finding a lot of varieties of conventional crops that are much more tolerant than everybody believes that it's possible. So if you just do these variety screenings of existing cultivars, you can find some very interesting varieties that appear to be suitable for cultivation under these moderate saline conditions. And that was the starting point for us many years ago. If you have all these crops that seem to tolerate moderate saline conditions, can we use all this salt affected land that there is in the world? Well, it's of course much more than just a crop. It's about the cultivation strategy if you want to implement this. It's about water management, it's about soil management, and a lot of different technical aspects. But also the socioeconomic factors are very important, of course, if you want to realize upscaling. You have to train the farmers, you have to showcase the results, you have to make sure there's a good market possibility for the crops that you are cultivating. And only if you combine all these aspects, you can come up with the right crop selection, with the good cultivation strategy. You have to provide the knowledge and the skills to the farmers, but also this market potential is really, really important. And only then, if you put everything together, then you can have something that is really scalable. So we're doing, for instance, some capacity building in Egypt, which is funded by the Dutch government. We're doing this together with Nectera and Delphi. So here we are really training university students and staff. It's classroom training, but also a lot of practical work in the field. So this is the first developing of practical knowledge and skills for these future extension officers. And we also implemented salt-tolerant potato that we found in Pakistan. We first introduced 8 different varieties, and with the local testing, it appeared that 3 varieties really had this potential for upscaling. So these varieties are now approved and are being imported by a lot of farmers. And the results were that we get close to 30% yield increase just by switching to this salt-tolerant potato variety. So there's a lot of potential for this potato variety in Pakistan, but also other areas in the world as well. And we also introduced a salt-tolerant carrot variety in Kenya. And you can see the picture that there's a big difference with the local variety. And actually this variety in combination with the cultivation strategy, in the end, we more or less doubled the yield. And also we came up with a solution to more or less stop using the fossil groundwater and really focus on the water harvesting, the rainwater harvesting during the rainy periods. And if you have a smart design of your field in that way, you can get close to 100% use of rainwater and rainwater storage. Use that later when you need it. So one of the bigger projects we were carrying out in Bangladesh. So there, the biggest problem was that only during the monsoon, most farmers in the coastal area are growing a crop. In the dry season, the salinity issues, they increase very rapidly. There's a lot of seawater intrusion. But because of building a local R&D station, showcasing the results, doing capacity training of the farmers, making sure that the input materials like the seeds are available, but also introducing drip irrigation, for instance, we were able to make these farmers more resilient and ensure that they were also growing crops in the dry season. You see some of the results here that the majority of the farmers are now using the salt affected land in the dry season. And then, if you start using these salt affected lands in a season that there's no crop cultivation, you have this whole cascade of positive effects, with food security, with employment, with the increase of farmers increasing, and it's going very well. So this is a nice example of the local situation that works well, and upscaling seems to take place very rapidly now. So we have an ambition to make a whole international network of different stations where you can do local testing, local capacity building, and also accelerate the innovation and really put saline agriculture on the international agenda and make sure we are reaching as many farmers as possible, because salinity is here already on a massive scale. Millions of farmers are affected, and we really hope to realize these ambitions in close collaboration with many partners to ensure that saline agriculture becomes possible and profitable. So just to highlight another interesting initiative that recently joined the work group of the FAO, it's the Sulfur project. It's a European project, and even in Europe, we're facing the 3rd historic drought in 3 years straight. So there's a lot of drought issues even in Europe, and farmers are looking more and more to adaptation, and hopefully this project will also ensure that there are good solutions that can be applicable for a lot of different areas where there are salinity issues. So, and of course there are a lot of opportunities, but also challenges, of course. So we have found some of these very interesting tolerant varieties of conventional crops, but those are existing varieties. And we're always trying to see if we can stimulate and involve the breeding companies to see if they want to embrace salt tolerance as a new trait for breeding. But that's more difficult than you often think. They don't realize or they don't see the market potential often yet. It's a big investment, of course, but there's room for improvement to produce even better salt tolerant varieties of conventional crops. But the implementation, of course, it's difficult. You know, it's not only the crop, it's also your soil and your water management. And it's quite a complex interaction, and you have to be aware of all these different disciplines. And often on an academic level, it's either crop or water or soil specialty, but a farmer has to know all these different specialties all together to ensure good yield under saline conditions, of course. And what we also see is that often local problems ask for tailor-made solutions. So if you do make these tailor-made solutions, you know, the results I showed, it seemed to work, but we need to get this on a higher level, of course. So we have to go from tailor-made to a situation that you can always implement specific crops and specific cultivation strategies. And that's one of the challenges that we're still facing, that we go from some positive showcases to real large-scale impact. And also these moderately saline tolerant varieties of conventional crops. Yeah, it's only suitable for moderate saline conditions, and there are a lot of areas with high salinity levels and high saline water that you can use for irrigation. Possibly even seawater can be used for irrigation, but then you really have to look at the halophytes. And that's the part that Cici will take care of in her presentation. So I kindly give the floor back to Cici for her presentation on the halophytes and the work of IGBA.
So thank you, Ariane. Okay, so we move on to the next one. So when we're talking about halophytes, and as Ariane mentioned, we are mostly focusing on plant species that can really tolerate at very high saline levels. So this is a very insightful paper that I highly recommend for those who are interested in saline agriculture. Within this paper, you can find different halophytic species which can be used for different kind of purposes. The next one. So they can be used for human consumption, as forage, as oilseed crops, energy crops, and phytoremediation, and as medicinal plants. For this specific presentation, for this specific part, we're focusing on the food and the feed aspects. Next, please. So the first halophytic crop, which I'm actually going to refer to and present some projects, is the quinoa. I'm sure most of you know, you have heard about the super nutritional value and qualities that quinoa has. So it has high nutrition, high protein value, high calcium, iron, magnesium, potassium. And the projects that IGBA is currently running on quinoa are the following. So first of all, we have the development of quinoa value chain in Morocco. And actually, why we're focusing on developing the whole value chain and not just just to improve and optimize the management practices. Because for halophytic crops, when the market segment is not there, first of all, we have to create the demand. We have to raise the consumers' awareness on increasing, the demand of these crops. And apart from that, considering the degradation of the soils, the increasing of salinity, to help the subsistence rural communities to enhance the food and nutrition and income security in these livelihoods, it is very important to secure not only the proper management practices for the crop itself, but the rest of the value chain steps too. So this is exactly the approach that has been adopted in Morocco by growing 5 IGBA stress-tolerant varieties, where exactly the Moroccan colleagues are focusing also in giving leverage to create and develop quinoa-based products. Also, for example, the farmers' cooperatives, the women cooperatives are participating in these kind of activities by also having a local branding name through which all these quinoa-based products are marketed and sold in the market. I also have to mention that through this project, because it is necessary to improve and to develop from scratch, probably in some cases, the machine and the equipment needed, for example, for harvesting the quinoa seeds or for seeds cleaning and processing. So I have to inform you that such type of machines have been developed in Morocco and are in the process of patenting. Apart from the machines, also the 5 quinoa ICBA genotypes have been registered under the Moroccan authority, the proper seed office authority. The second project that took place in Kyrgyzstan also followed the same approach by developing the quinoa value chain and having some pioneer farmers who were the leading examples in the region to adopt and to propagate through proper, of course, field days, through extensive capacity building and training programs to expand the cultivation of quinoa in the region. Next, please. So the next halophytic crop I'm going to talk about is the Salicornia. The common name is sea asparagus, sunfire. It's very popular in some countries like Netherlands, UK, Belgium, France. It's considered a gourmet type of dish in some of the regions. So it can be used for human consumption, it can be used as feed. And of course, the seeds have good oil quality, approximately 30%. That although these are at very pilot stage right now, they have potential for biofuel production. So currently, the ICBA team, in collaboration with a nutrition expert, we are evaluating the nutritional properties of Salicornia, and we are comparing, for example, with asparagus. So what we have observed, for example, is that the minerals content is much higher compared to asparagus, and there are more sugar and healthy fats involved, more fiber, more calcium, magnesium, and manganese, which of course these minerals have and impact our health in a beneficial way. Next, please. So Salicornia, for the last 6 years, constitutes a very important part of our integrated agri-aquaculture farms developed by ICBA team. So the concept here is to utilize the reject brine from desalination to grow the fish, and then the water from the fish is directed to grow the halophytic crops, halophytic forages, Salicornia, other halophytes, for example, like quinoa, in the field. And also for the last 2 years now, we are developing the saline aquaponics, growing Salicornia and other halophytic vegetables too. The next, please. So this type of integrated farming approach is implemented under a current running Expo Live project. Several partners, prominent national and international partners are involved, and of course our aquaculturists and nutritional experts. And as I mentioned, the concept behind this project is how we can add value to the reject brine from desalination, growing marine species and halophytic crops. So we are kind of doing intermediate scaling up in 8 farms in UAE. So we brought the Salicornia and the integrated farming approach from the research level at ICBA's experimental station to a farm level. We are also focusing on developing Salicornia-based food products, and definitely, since we are irrigating we are irrigating Salicornia with reject brine from the salination directly in the soil, we are very much closely monitoring the environmental impact, and of course, what are the benefits from financial point of view of the products of the produce of the halophytic and of the fish biomass. Two challenges that we really faced under this project. First of all is when it was about time to harvest the non-uniform plant height of Salicornia plants, which of course strengthens the importance of having improved halophytic germplasm when we're implementing scaling up projects. And the second point was the fact that we have to develop machines and equipment to accelerate the harvesting of Salicornia fresh tips. The next slide, please. Yeah. So the vision of this project is actually to develop a sustainable halophyte-based industry model in a desert environment that could be further replicated, of course, looking into all three sustainability pillars, social aspect, financial aspects, and of course, the environmental aspects. Next, please. So just to give leverage also to what we are creating, because as I mentioned before, if we are not only focusing on the cultivation per se, we also have to look into the rest of the value chain steps. So you see here some of the halophytic dishes that our chef created in 2018. So you can see different kind of versions of Salicornia being utilized as ingredient. And currently, this year, we are developing products in a more, let's say, commercial and in a more, let's say, productive way. So we have developed Salicornia burgers, smoothies, biscuits, crackers, and the recent, let's say, product that it's currently under further improvement by the global food industries and a great partner that is food company that is collaborating with us on that aspect is the Salicornia cheesecake. So yeah, next one. What we have also observed throughout running several projects related to halophytes, we have identified some gaps considering the public awareness. Although some of these crops, for example, Salicornia, is very popular for the chefs, okay, because they are utilizing in their dishes, but the public is totally unaware of what Salicornia is. So in order for us to give leverage to raise the public awareness, to increase the consumers, to increase Salicornia demand by the consumer, by the public, we have created a current initiative, a current activity, which is called the Halophytic Kitchen Lab. So we have students and adults on board who are going to get involved to participate in interactive live cooking sessions. And apart from getting familiar with the halophytes, with cooking different halophytic products, they are also going to learn the nutritional aspect and the nutritional benefits of the halophytes and being used in their diets. Next, please. So the second project, which is funded by HSBC Bank, is implemented in 2 countries, in Egypt and in UAE. So in Egypt, we are implementing two different kind of trials. One is the quinoa value chain in New Valley, and the first part is in collaboration with the Desert Research Center. And the second component, the Salicornia production trials, is in collaboration with the Ministry of Land and Agricultural Development in Egypt. The third part refers to the training and developing smart applications and smart training modules, which are translated in different languages, because our target is to reach the core of the people who are really practicing agriculture. So we are targeting the workers, we're targeting, the farmers who really need this kind of translation in order for such kind of saline farming saline farming approaches and saline farming models to be implemented in the most proper way. Next, please. So as I mentioned, the quinoa trials are implemented in New Valley. So currently all 5 ICBA quinoa genotypes, the ones that were tested in Morocco, they are also tested in New Valley too, in Egypt. And out of these, the local farmer cooperative has developed some quinoa products using this quinoa, which actually these products are going to be showcased in a food exhibition whenever the lockdown measures are relaxed and of course the social distancing is safe. The second component, as I mentioned, is the salicornia. For the time being, the primary focus is for the feed use, not for food. And we have tested salicornia. We are evaluating salicornia in 2 locations at the Red Sea Governorate in Marsalam and Shalatin. The interesting outcomes that are currently being observed are the differences of the response of genotypes at different locations. So we have a regional variability, and also on the different plant morphological and growth stages too, and characteristics in general of the plant characteristics. Next, please. So now I'm going to present to you some photos from dishes, halophytic dishes that I personally experienced with some other colleagues in the Saline Futures Conference last September in 2 islands of the North Sea in Netherlands. So you see different versions of dishes, salty sweets, that were halophytic plants, local halophytic vegetation was used as ingredient for these recipes. These recipes were prepared by local chefs at their local restaurants. And for me, that was an excellent example of how such a kind of approach can be adopted in other regions and countries too, where there are salinity issues. These are some other halophytic products like condiments or cosmetics products where halophytic plants were used as ingredients. Next, please. So now we move to the challenges that we have observed so far, and we are directing more our research focus on this. Is first of all that we have to, when we are doing the scaling up and improved halophytic germplasm, then we have to mechanize the harvest and the seeds cleaning processes. This is a very vital component, because through this we are going, first of all, to achieve a higher yield, and of course we are going to minimize the time for the harvest process. So ICBA now is focusing on this point too. As I mentioned, we have to customize the halophytic production on the local climatic and socioeconomic context. I have to highlight here that we are not talking about saline agriculture, which is implemented horizontally in whatever region, whatever climate, whatever conditions exist. No, we have to customize, and as I mentioned, we have to tailor-make all these different kind of approaches to the local climatic and socioeconomic context. We have to consider the different salinity levels of the water, of the different soil types, even the different climatic conditions that exist in the regions. The fourth point is the sustainability of saline agriculture projects. The common question that we have when we're talking about such farming approaches is the soil, is the salt, the salinity buildup in the soil. So of course, I fully agree that this is a kind of approach, and always we should direct our focus on that, so that we can have all 3 pillars, let's say more or less being taken care of, in the sense of sustainability, in the sense of environmental, from environmental point of view, from a social point of view. For example, we want these crops to give income to the local communities. And of course, from financial point of view, and acceptance, social acceptance. Creating the market segment for halophytes. So I repeat again that there is no point in discussing about halophytic crops and about their cultivation if we do not focus on the rest steps, on the rest stages of the value chain. This is imperative. And also we have to not only to focus on, let's say, experts on food companies, for example, to uptake these halophytic plants. We also have to increase and to raise awareness and so that we can increase demand from the consumers side of view. So such type of activities to inspire the art of cooking or culinary events, to attract the public, the consumers, the students, whoever, is very important element too in the successful implementation and adoption of saline agriculture. And last but not least, the training, capacity building, farmers how to implement properly the saline agriculture farming practices is vital. So for example, how they are going to utilize the saline water resources in a sustainable way through decision support tools. This is very important element, and also how they can manage the soil. So these different kind of decision support tools are going to be further explained and elaborated to you by my colleague Andres. So now I give the floor to him now. Thank you.
Thank you, Sisi. Hello, everybody. First of all, thank you very much to the organizers and the other participants of this webinar. It's a real pleasure to share it with you. And of course, to all the people who is at the other side following on these challenging times. I'm Andres Parra Gonzalez. I'm part of the irrigation department at WASAG, which is a reference research institute for agriculture in semi-arid areas, and it's in Murcia in Spain. And as we have seen, there are several strategies that farmers might take in order to adapt their farms when they face salinity issues. So to help them to design these strategies and improve their farming methods or results, I will briefly present now a decision support tool that we are working on, which combines water management and crop performance to improve the results and the saline conditions. And just to highlight some general facts at farm level, I want that it's like farmers are dealing with in the Mediterranean region, although they could reflect what happens in many areas affected by salinization worldwide. So we have that in one hand that it is common that irrigation systems are not really efficient, and sometimes farmers have to use different water supplies to irrigate their crops. These crops that in many cases are irrigated under the same regime, but also exists a limit reliance on non-conventional waters like saline waters or brine, brackish, reclaimed wastewaters, and this is due to general uncertainty about the effects that these waters might have on their crops or even in their soils. Another fact is that the majority of these farmers are smallholder farmers who normally use low-cost technologies, and for different reasons like difficult access or lack of information or economical issues, there is not a common use of modern solutions. Next, please. Sometimes if an alternative water supply is available, as I said, for irrigation, but it's not fully adequate in quantity or quality, blending waters might offer a solution. The goal of blending is the goal of blending waters is to increase the volume of suitable irrigation water which highly will depend on the salt crop tolerance. So this is one of the objectives that we have in this project in ProSim, which is a project which just started a few months ago, and is aiming to reduce the pressure on freshwater resources by means of sustainable irrigation management and the use of non-conventional waters for agriculture in the Mediterranean region. And it's a cross-border project with the participation of Italy, Jordan, Lebanon, Tunisia, and Spain. And we are, when we use, as I was saying, when we use non-conventional waters for irrigation, or we are mixing waters of different qualities for certain reasons, it requires an improved management of different aspects. We need to identify the right crops and define the proper rotation in case that we are doing a rotation, select an appropriate irrigation method to ensure that soil salinity or sodicity are controlled, and of course have a rigorous monitoring of our activities at the farm. In this sense, we are working on the development of a decision support tool to manage different water supplies to help farmers who have to deal with these issues. This way, we will be able, or they will be able, to contrast their personal knowledge and experience with reliable data in order to improve their management, exploring multiple alternatives and identifying at an early stage and predict situations, which will result in a reduction of cost and time. Next, please. Yes, thanks. Well, as I said, when farmers have different water supplies with different quality and they have the possibility to mix them, they can consider, or they have different strategies or options regarding not only the irrigation method, but also the crop management. So the idea at this first stage of this decision support tool is to develop a low-cost and user-friendly technology like a simplified Excel tool which process input parameters on water quality and some crop details, which will be entered manually by the user to return the best mix of water qualities and quantities for the chosen crop, as well as some information about the relative yield of that crop under saline conditions, or if this crop has a more sensitive or a more tolerant growth stage, or if it could improve even the taste. Well, we have to see, but and in function to that, the farmer will be able to select a proper mix for the irrigation. Also, if it exists the risk of toxicity hazards or problems with water infiltration, they will be able to see it in advance. We want to include a fertilizer recommendation based on the result of that blending. So in summary, what the user will be able to explore several scenarios regarding the water management and crop performance, and then select the option that better fits the requirements of the farm. Next slide, please. Okay, so if we focus on good agricultural practice that optimize the irrigation using non-conventional waters, we will be able to reduce the pressure on fresh water resources. And as we have seen today, there are different options to adapt our farming systems depending on the needs. So if in this way, new technologies are an important ally. And at this first stage, we are focused on a simplified tool which with basic but relevant information for this crop cultivation under saline conditions. But we know that during the project and once that this tool starts to run, it will be improved by means of the feedback from even the farmers or other users and stakeholders. And who knows, maybe after the webinar, some of you have comments that we can take that input. Okay, next, please.
And Andres, sorry to interrupt, but you are running really late. If you can.
Yes, that's just the conclusions, and thanks. Well, so the presentation is reaching the end, so I will just mention some conclusions coming out from the different talks. What I can summarize saying that saline agriculture is feasible in salt-affected areas through multidisciplinary approaches based on tailor-made solutions. It's known that we need to improve the germ plans of salt-tolerant varieties or salt-tolerant species, but also the management practice in salt-affected areas. And we needed to develop that value chain for halophytes, which is imperative, and raise that public awareness. And so I invite to all of you to consume more halophytes. They have a lot of benefits, as we have seen. And to transfer this knowledge through training and capacity building is really needed. And just to end with these digital technologies that might play an important role, as they can facilitate many of these activities. Yeah, that's all from my side, and we'll have another webinar next week that from here I invite all of you to join, and thanks for being there, and it's I pass my time. Thanks.
Thank you very much, Andres. Thanks, Cici. Thank Arjen for your sharing with us your experiences. It was a very interesting presentation. I wish we had more time. So we apologize for everybody. We are running a bit late. But however, I would there is a lot of questions, and unfortunately we cannot address all of them. I'm gonna pick only 3, 1 per each speaker. And please, speakers, if you could make your answer within 1 minute, please, if possible. And then the remaining, we will try to address them and send you emails. And we will also display the email of the 3 colleagues so you could answer, you could engage in discussion with them. So my first question, we will start the reverse to Andres. So Andres, many people ask about what's the impact of irrigating with salty water, and what are some of the strategies that we need to use to make sure that we are not increasing the problem of salinity in the soil. You are muted, Andres. You have to unmute yourself. Or Rosaida, you need to unmute him? Yeah.
Well, yes, I said I think that it's really important to have a close monitoring of our activities. So if it's we are using brackish water, we need to know that we need to measure that how the soil salinity is increasing. That we have to take into account that we are using an appropriate leaching fraction, or we have good drainage systems to leach those salts, and of course depend of the crop that we are using, the texture, soil texture. We will have some strategies, or we will choose some strategies or others to fight that increasing of salt using this kind of saline or brackish water. But of course, local conditions have local answers.
Thank you, Andres. So thank you for being succinct. I'm going to move to Cici. We got a question from Iqbal on the impact, the health hazard from consuming salty plants or plants that had halophytes that have been irrigated with salty water?
Yeah, that is a very good question, and we are always, let's say, facing such kind of comments and about the consumption of halophytes. So for humans, I suppose, right? We're talking about food products.
Yes, human, yeah.
Okay, so since I'm more deeper involved in this kind of developing, let's say, the Salicornia-based products. So in some cases, Salicornia is replacing the salt in processed food products, whereas when we are using it as ingredient for example, when we cook it at home and we have the potential to, for example, to boil it, then all the salts are coming out. So when we can consume Salicornia after just kind of steaming it or boiling in the water, then it's safe for consumption. So this is the experience so far. As I mentioned, currently the ICBA team is in collaboration with nutritionists and with doctors to see how the different kind of processes impact our health, different kind of operations, and what kind of benefits in the end they have.
Thank you very much, Cici. My last question then that I picked is for Arjen. And the question, Arjen, it's mostly, could you give us some example of strategies that you use when you are talking about low salinity levels and talking about vegetables? So could you give us, is it the varieties that are tolerant? Is it the management? What are the strategies that we are using in those examples?
Yeah, thank you for that question. So for us, it always starts with the salt tolerant crop. And yeah, actually, it starts before that if you really look at adaptation, you first measure the level of salinity of your soil, possibly your irrigation water, and then see which crops are still suitable for cultivation. So for sure, it starts with a salt-tolerant crop, but the soil management that you can do and also the tricks you can do with your water management, they have a large impact on the eventual crop yield. You have to look at the fertilizers you use, and you have to come up with some mitigation effects. Sometimes you can even use prevention to make sure it doesn't get worse, because it's not just about one crop season. No, it's about sustainable farming. So we have to come up with solutions that work crop season after crop season for sure. But yeah, in short, it's a combination of choosing the right crop together with your soil management and your irrigation management.
So I think I see we have some time. So maybe I'm going to give one question to all of you, the three speakers. So there was many questions. Of course, everybody asked what's happening in Egypt, what's happening in India, what's happening in Bangladesh. But in general, I would like you to pick a country that you want and tell us what are the potential of biosaline agriculture. Do you think it's doable? And if you want to take one example, either in Africa, Asia, or MENA as an example, please go ahead and expand on it. Maybe everyone 1 minute or so, that would be nice.
Cici, you want to go first?
Ladies first.
Okay, ladies first. Okay, thank you.
Questions from many countries. There was Ethiopia.
Yes, yeah.
India.
Okay, so since last year, I've been working on halophytes and the Salicornia scale-up and this integrated farming approach in UAE. So when we had this request from Egypt and the Ministry of Land and of Agriculture and Land Reclamation to move to the to scale up the Salicornia at the Red Sea Governorate, and when we had this first visit and I saw these vast regions there that could have a potential for biosaline agriculture, this was a real challenge for me and for the ICBA team, of course, to move forward. Definitely, saline agriculture has a potential, but I have to highlight that we have to have a multidisciplinary approach. We need much different kind of expertise. We need irrigation scientists, soil scientists. We need agronomists to focus on the sustainable side of the project. And as I mentioned, it's very important to focus on developing the whole value chain development, especially when we want this crop really to be adopted in the local communities. So this is my concept and thinking and approach. Thank you.
Thank you. So, Andres, Arjen, whomever want to go first.
Arjen?
Yeah, sure. So yeah, it's difficult to pick a country or region. I think you know, we work in many different countries. For instance, in Egypt and Jordan, you know, the more arid part of the world, the problems and solutions are very different from countries like Bangladesh, where you have a specific monsoon season. But we did the most work in Bangladesh, and to see that during the dry season, most farmers stop cultivating their land. You have this seasonal migration, looking for work, you know, all these people. And then to see that we can come up with good solutions that combines like rainwater harvesting during the monsoon, underground storage, using that water for irrigation during the dry season, and come up with very good market values for the vegetables the farmers are growing. You see this increased consumption of the vegetables that they're growing. So part they're eating themselves, and part they're selling on the market and getting a good profit. So you know, the people are not migrating away anymore. And a lot of people that migrate seasonally, you know, they also often they stay away because the salinity issues are becoming more and more severe. And now with the cyclone, you know, these farmers are really struggling to survive. And we see the same thing happening in deltas like Myanmar and Vietnam, you know, the seasonal migration. But yeah, with this year-round strategy that you harvest the rainwater, and you have these tolerant vegetables with good food nutritional value, a good market value, you know, we're really making a difference there. And I really think that can be an example that can be quickly scaled up for sure.
Thank you, Arjen. Andres, please.
Yeah, well, I shared a lot of time. We also with Arjen in this project in Bangladesh, so I have part of my experience here. But it's I see that for now I'm in Spain, and I see the potential that we have in Spain to scale up the saline agriculture. And there is we are known as the Garden of Europe, and more of the fruits and vegetables that are consumed in Europe come from these really arid areas in the southeast. And I think that if we use more, with farmers here, will use more tolerant varieties and adapt their farms to these saline agricultural systems, or use more halophytes, it will be really easy to do a scale up. But of course, as Cici said, we have to convince the consumers and explore better that value chain that halophytes might have, and so there are things still to do.
Thank you very much to all the speakers. As an ICBA DG, I want to just jump in and say really the value chain approach is very important. I saw many questions on crops that they don't have a market. And I think really our experience in ICBA, for example, in some countries, if I want to take Morocco as an example, in El Ayoun, we had a very successful project with forages, with a co-op of farmers, with UM6P and Fosbokrah Foundation. With IDRC, we did the value chain of quinoa in Belgrade, which is a very, very harsh environment as well in Morocco. So value chain was the solution for us, and the multidisciplinary approach and all the components, because the nature is complex. So we cannot simplify it. We have to have all the disciplines. So with that, I want to really thank our speakers and give a chance to my dear friend and colleague, Eduardo Mansour, the Director of Land and Water Division of FAO, to give us his concluding remarks. Eduardo, the floor is yours.
Thank you very much, Mahan. Thank you for the participants for enduring the session. I have to say that FAO is very pleased and happy to host this webinar organized within the framework, the Global Framework on Water Scarcity in Agriculture, the WASAG, by the group co-led by ICBA and the Republic of Iran. We are very honored to have the result. of this information and the wealth of information provided and the questions that came can show the importance of the topics. The dimension, one thing that called my attention in this, to conclude the event, is the dimension, the scale that we have to face. I mean, Aaron, you mentioned 400 million hectares of salt-affected areas in the world. We are engaged now, we think, by the preparation of the world map of soil, saline, salt-affected soils. I unfortunately have to say that the figure is higher. Angela Moreno, one of the participants, commented on the difficulty of having reliable mapping in this particular case. But if you add salinity and sodicity of soils, then we are talking about a figure of 1 billion hectares affected. And these maps are going to come up by October. We are going to have them ready. They are much more precise than the ones developed so many years ago. So we're working very hard using new techniques and also of remote sensing and also sample field sampling for the precision of the maps. We noticed that the topic gained a new dimension. For old timers like me, it's easy to see that we evolved a lot from the idea of desalination to the idea of a saline agriculture. The number of crops varieties that we are dealing with is much higher. The alternatives for water resource management, for combining crops with aquaculture. This has been all novelties that are bringing us a new wave, which is particularly important, not only for fragile environment, but also to face the current conditions that we are in this crisis, that we need to generate more jobs, we need to generate occupation, we need to produce food locally, we need to manage better our water resource because the competition for water is very strong and is likely to increase. So in this set, I think we are moving to the right direction. The issue is very big, and we are not afraid of it, but it requires another step of discussions. And as Andres mentioned, next week on the 2nd of June, we have another webinar of WASAG focusing on the water and soil management on saline environments, or salt affected. So please join us on that one as well, because it will complement nicely what we discuss here on techniques, on crops. I would like to thank particularly my dear fellow panelists, the presenters, Ambassador, Your Excellency, very nice to have you with us, and my dear friend and Director General of the International Center for Biosaline Agriculture, Ismahane. Great pleasure to join you. We had an average of 300 participants and with us during this session. As is a practice in FAO, the webinar is recorded and will be available online at the WASAG page. And the questions, I hope that will be addressed correctly. It's a large number by the panelists in due course. So I thank you very much, and I wish you all the best. Thank you. I think you're mute now, Ismahan.
Thank you very much, Eduardo, for your concluding remark. I think you said it all. I would like also to stress to thank everybody that got involved, from the 3 speakers that were excellent, from FAO, the organizers, and the colleagues from ICBA that were behind the scene. Your Excellency, Ahmadi, Dr. Ahmadi, thank you very much for being with us. He's our co-chair of the Biosaline Agriculture. We are proud to have that collaboration. Thank you very much for everybody, and looking forward to see you all next week. So tune up next week for the next chapter. Thank you very much. Thank you, Rosaida, for all your work as well, and Jean Boroto as well. Thank you, guys.